Hi, Cal State Straub. Here we are for day 2 of 13, section 1. Still continuing on two sample tests about a mean. Typically, most of that's going to be two sample T. As we've talked about, two sample Z is not very often to happen, although it's done similarly using the Z table and your sigmas instead of S's. So before we get into finishing up a little bit on that, I have here 3 problems for you to look at. I want you to determine for me whether these tests, I want you to read them and determine if it's a t-test, a paired t-test, or a two-sample t-test, okay? So the first one, you're looking at an SRS of college students to see how many hours of sleep they get a week. Some of you are heading there soon. Another SRS of high school students were asked the exact same question. Okay, so now you decide what type of t-test would I run on that one. Okay, the second one is a high-profile company claims that its average productivity in an hour is 132 products. So in a random sample of 40 hours of work, on average, 125 products were made with that standard deviation. Now, what t-test would you run on that one? And then the third one, the doctor is doing, let's see, what it says is their evidence that the company is overestimating their productivity. So there's, sorry. 3, the doctor is doing some research on a new drug to combat high blood pressure. He has a random sample of patients who suffer from high blood pressure, and he measures their blood pressure for a baseline, gives them the new drug. After an hour, he measures their blood pressures again to see if this new drug lowers the blood pressure. What test would you run on that? So I want you to answer those 3, but then when you're done deciding which test to do for which, complete the test for question number 2. Okay? And I'm going to have you go to Edpuzzle with this one. Okay, hopefully you saw that first one was a 2-sample t-test. 2 completely different samples, college students, high school students, not the same populations. So that was our new one, 2-sample. Number 2 was the regular old 1-sample t-test we did last chapter. And hopefully you ran that 1-sample t-test on the data there. Number 3, that is an example of paired t. Same people, a before and an after is a paired, okay? Just to see how you did with the test, you can compare here. Of course, you needed to state your parameters, ho and ha. I just kind of did a quick run through here. Right here, you can see my parameter is the mean number of products produced in an hour. Okay, we need to say mean, not average there. That's why I put that in parentheses. Your ho and your ha, since it's less than is the ha. This is a 1-sample t-test, so I did the SRS. I could use CLT for normal because it's for means, and then the independence checked off. Here's my degree of freedom being 39, ran my t-statistic, and in the calculator, you would have gotten a p-value of 0.000227, really, really, really tiny. So we do have statistically significant evidence at this 0.05 level and at the 0.01 level, for that matter, to reject the HO and conclude the average number of products per hour is less than 131. So that was just a quick review of last week. Now, before we go into today's actual notes, you were asked to have this worksheet ready for today's notes, the estimating a difference in means worksheet. And I'm going to just give you some notes to review from yesterday that I want you to begin to fill into that worksheet. We're going to do the back of this worksheet after today's notes. But just as a reminder of what we learned yesterday we talked about what is a 2-sample t-test and how to set up the ho and the ha's. So before that, I just have a quick It says here prerequisite knowledge, our background knowledge, our habit of the mind we keep referring to a lot right now. We're relying heavily on that background knowledge one coming into play. Remember what a sampling distribution is, that it's the distribution of values taken of a statistic in all possible samples of the same size from the same population. You had to regurgitate that to me a few times before the pandemic sent us home. Okay, but here, what if we want to estimate the difference between the means of two populations? Okay, so it says, for instance, maybe we want to estimate the difference in the means. Remember, when you're estimating the difference in the means, that's a confidence interval. Okay, if we're going to run a significance test on it, then we would do significance testing, t-test. Okay. So it just says here, maybe we want to estimate the difference in the mean amount of time spent playing video games last week by male and female students at a large university. So they're going to compare two separate populations, the males and the females from this university. So it just says, how should we collect this data? Well, remember, all of this has to be random sampling, and we have to take a random sample from each population, and then we'll compare those sample means. So I just have here that you're going to take an SRS of size N1 from population 1, size N2 from population 2. Okay. Our best guess at the value for the difference of these populations is going to be the estimate of the means of those populations. So we're going to take the difference of those two, and that's going to be our best estimate towards what's the truth about the difference between these populations in the means there. Okay, so describe the sampling distribution. Okay, I'm going to pull this up now if we had time. If you didn't, then pause and continue to write. All you need to do is continue to finish this page. Okay. Here's what we have down for the shape. Remember from our past that population distributions are, if they were normal, then our sampling distribution is normal. But in other cases, it will be normal when you have CLT apply, when n is greater than or equal to 30 for both of them. The center of our sampling distribution is going to be this x bar 1 minus x bar 2. That's our great estimate of mu1 minus mu2. And then the standard deviation of this sampling distribution is this new, we call it actually the standard error, the SE formula here, that we looked at yesterday. As long as there's no more than 10% of the population for our sample size, and that's our 10N condition, okay? So these are just the general things that's connecting us back to sampling distribution, reminding us that that's what we're doing here. This sample we're taking as a representative of this sampling distribution. Before, just note that down here, mine says chocolate chip cookies. That's on your back. Just remind me, we're going to do an example using the chocolate chip cookie problem on the back, but not until after I run through today's notes, because you may choose to use your calculator instead. I know. I would prefer the calculator commands with these crazy two sample. So we're going to go over that first. Okay. All right. Let's hop into the few notes for this day to finish up. There it goes. Okay. Comparing two means still, from two separate populations. I mentioned yesterday that I was going to go show you where this was on the formula sheet, and I promptly forgot. So I made a copy of it here and stuck it here. This is what your formula sheet looks like, the sampling distribution for means. Oh, I just went over that, didn't we? So remember, for one population, this is what we did last chapter. Okay, if you know sigma or don't know sigma, right? And then what if it's two populations? Two samples that we're doing, and here's that lovely little formula we've been looking at for your SE. So they do give you that on the formula sheet right there. Okay, so you don't have to remember this crazy stuff that's going on inside the square root. You just need to look at your formula sheet to find that. Okay, now what about our two sample T? What does its distribution look like? Okay, so remember, a t distribution is not exactly normal. The bigger n gets, the more normal it gets. It's still symmetrical, it's still mound shaped, but it's just flatter in the mound. Okay, so when we get our two sample t, this is the degree of freedom that helps us get to that t distribution. This formula was in your book. Crazy, crazy formula, but if you start looking at the pieces, it's really not as crazy. Some of this can start making sense. Where we are right now, where we're not in the classroom, I'm not going to spend the time to try and go through this crazy formula with you. Just know this is a very, very accurate formula. It's what your calculator will be using to come up with the DF, which will be different than the table, okay? The tables, remember, a conservative estimate for our n's. So they use this one. It's as long as n is greater than 5 for both of these, this is very accurate. When we get n smaller than 5, then it's not as accurate, okay? But usually you don't do samples that are that small. So that's why computers and calculators being used is really nice to come up with your DF. So let's talk about that calculator command, because I honestly, guys, if I were you, this is what I'd want to do. If you're given data, you know how to enter your data. Your first population data should go into list 1, then your second population into list 2. Okay? Once you have that data in list 1 and list 2, now, mind you, this would be the option to choose data right here. If I have stats, then I'm going to go ahead and put in my X bar 1, X bar 2, S1, and S2 when it prompts me. But right now I'm saying, let's just say you have raw data and you need to compare the data. You're still going to do the stat tests, and you're going to go to the two sample t-test, picking data here. I tell it where my list 1 and 2 are, where my data is, 1 and 2. Leave these frequencies alone. You have to choose whether it is two-tailed or one-tailed, in which direction, left or right. We're going to talk about pooled in a second. Leave your pooled as no, and then hit calculate. If you hit draw, you can get a little normal curve-ish looking thing that shows you the sketch, okay? It doesn't give you the numbers on it for you to use for your own sketches, but it gives you a rough sketch that you can compare and make sure yours is right. Okay, when you're done, it will give you this data over here on the right, all of those pieces of information. Okay, I've been trying to explain to you with this long distance learning, this is crazy, but on your paper, if you use this command, you need to do everything that I did right here. You need to write down everything you're putting in. If you're going to do stats, then you need to put what stats you've entered in the calculator. Like I said, if you're entering X bar 1, S1, X bar 2, S2, if you're entering stats, then you've got to list it. Then I highly recommend you go just like this is. Oh, come on. My calculator. Sorry about that, guys. It's moving on its own. You go over here and show exactly what you get out, what you put in, what you put out. If you're not doing all the work to calculate this t statistic by yourself and going to the t table and getting the p-values on your own, this is the work you have to show if AP is going to give you credit, if I'm going to give you credit. So show what goes in and what goes out. It's really nice to have an input and an output right next to each other, every single piece, okay? The reason I'm harping on that is because on the last few quizzes I've been grading, I have not been seeing that, and I've had to write you a lot of information, like what did you put in when you did TCDF? What is that first number? Oh, that's representing negative infinity. Then you label, that's negative infinity. Label the next one, T statistic, negative 3.33. You need to label them, okay? So when this is a great procedure, I think for two sample where there's so many places you could make simple mathematical errors, this is fantastic. You'll end up with your T, your DF, your P. You're going to get everything, the p-value. Everything there will show up. This is super easy compared to doing it all by hand. However, do it by hand if you wish. No, it's up to you. Okay, what about confidence intervals in the calculator? Okay, again, you can run your two samp t interval now, not t test, but t interval, t int. If you're entering data, again, you do the same things that the last one had. The only difference here now is that you need to enter the confidence level, which is whatever, 95%, whatever it is. Again, pooled is no, and then hit calculator. calculate. When you are done, you will get your interval, your DF, and all your pieces of information here. Okay. Again, much easier, quicker to do, but you certainly can do it by hand as I showed you the formulas yesterday. Here's just the quick note on pooled. We don't pool. I'm not going to take time to go into this for this course, but it was heavily used before we got calculators and computers that could do this for us. And so I don't even know why they leave the command in the calculator, to be honest. So just don't even worry about pooled. It's something that had to be used trying to get some more equity in the data to be able to use normal condition. Okay. All right, so let's get to an example. Okay. Is there evidence that calcium decreases blood pressure in African American men? So an increase in blood pressure here is a negative response when you see the data. So there was one group of African American men that took calcium, and this was their increase or decrease. Okay, so this is weird. An increase in blood pressure is a negative thing. Let's think of it that way. So -4 means that they showed actually an increase of 4. The group 2 took a placebo, thinking they might have been taking, they didn't know if they were taking calcium or not, either group. Remember, that's important when we're doing a drug in a study. And there's your information on group 2. Okay. So your HO is that there's no difference between the two, that the calcium does not make a difference. But we're wanting to see if there's evidence that the blood pressure decreases. Okay. So that means our calcium needs to be positive. Remember, positive is a decrease. Negative is an increase here. It's kind of weird in this problem. Okay. So our HO is that the calcium's mean is greater than the placebos. Making sure to note our parameters here, okay, so that we have our identification clear, and then checking our conditions. You didn't have the data here, but I'm just telling you both were. Notice I said both were. We have to talk about both. SRS. If normal, yeah, when you put this data into your calculator and check your plots, they look a little wonky. So I would not say these are actually fairly linear. So we're going to proceed with caution on that one. And then remember, you're independent. Of course, there's more than a 110 or 100, because the first one of them has 11 numbers, one has 10 different ends there. There's more than that many number of African American men, and then these groups were independent of each other, is our assumption. Okay. Continue with the problem. What you need to do is then run 1 var stats on each of the data. So I'm going to go back. Did you have time to put all of that data into your calculator? Make 2 separate lists because you're going to run this for me. Okay. If you need time to put that in, then pause and put it in. You're going to run 1 var stats on your 2 sets of data. And that will give you the items to fill into your formula. Or you can choose to run it in your calculator. And you don't need to run 1 var stats. You can just run a 2 sample t-test. Okay. So when I run 1 var stats on each L1 and L2, I come up with these numbers. So check in your calculator that you did the same. And then here's my T statistic. When I ran a t-test, I got 1.6037. So very, very close to what this is. Okay. Our DF is going to be 9, the lowest, smallest, and -1. Okay. So I'm going to stop an Edpuzzle here and ask you to give me a conclusion. You either did it on your calculator or with this 1 var stats. And what would be your conclusion for this test? I got T to be between these two numbers on the table, which goes up to a p-value. If you did the t-test, two sample t-test, you got 0.0644, which is between the 0.5 and the 10. So since p is not less than 0.05, there's not enough evidence to reject the HO. So we conclude that calcium is not likely decreasing the blood pressure in African American men. We don't have enough statistically significant evidence to say there is no difference. So, or that there is a difference, that we have to accept there is no difference at this point. Okay. Right. What if you had to create a 90% CI with the same data? Okay. Remember, this is your formula for the CI. Now, again, you could go to your calculator and do 2 T int and come up with it, or you can go ahead and put in the data that we are reusing in the last chart. I want you to go to Edpuzzle and tell me what interval you got and your conclusion. Okay, I just filled in the numbers here, did the math, and I got that interval. If you did T int in your calculator, you're going to be more accurate. So this interval could actually be smaller than this, not as wide as we are. Remember, the table takes it more conservatively. Okay, so we are 90% confident the true mean blood pressure, the true mean difference in calcium blood pressure and the placebo blood pressure was between these two numbers. Here I showed you what I got if I ran the t-test. You could see here we got a little tighter. That this is what I was talking about. It's being smaller, not as conservative as this one. We were able to tighten it up, which is good. Why we use the calculator. If we also notice, 0 is smack dab in the middle of that. So that leads us back to that decision that we made. If you recall, this was a two-tailed test. If this is a two-tailed test, then I could say, hey, there is no difference. 0 is in the middle, and so I'm going to fail to reject that HO and say that there is really no difference between calcium and the placebo. Okay. All right. With that in mind, we are going to go back to your worksheet now, and let's go here, and we're going to do the back page. You're going to do that and share out your results with me. Okay. And here's 2 students who are doing their AP capstone project, and they want to know if generic chocolate chip cookies have more or fewer chocolate chips than the name brand chocolate chip cookies on average. So they got 10 bags of Chip Ahoy cookies and 10 bags of Great Value cookies, the generic brand, randomly selected 1 cookie from each bag. And then they broke open each cookie and counted how many chocolate chips were in each one. So here's their results. Okay. What it's asking you to do is to run a CI, confidence interval, 99%, for the true difference, mean difference in number of chocolate chips per cookie between the 2 brands. This is definitely a 2-sample t-test. T interval in this case, because you have Chips Ahoy and Great Value. They're completely separate populations. Okay, so go ahead. Don't forget to check your conditions, your state, plan, do, and your conclude for the interval. And then at the bottom, it asks you, does your interval provide convincing evidence that there is a difference in the mean number of chocolate chips? Explain. So since this is a 2-sided t-test that we are running, we need to see if our hypothesized value is in the interval or not. If it's in the interval, then we're going to fail to reject the HO. If it's not in the interval, then that leads us to rejecting the HO. So try to work through those 2. Come back and give me your answers, and I'll show you my key. All right, take a quick look at what you should have gotten here. You ran a 2-sample T interval. Our degree of freedom, the 10 minus 1, there are 10 cookies in each. So notice here I ran the T interval formula up there to remind us. Here's where I listed my 2 separate parameters. I call mu C to be the Chips Ahoy mean, and UT 1 and 2. I guess I went back and called them 1 and 2 to be the great value ones. Maybe I had to start with a G, but then I guess I went back to 1 and 2, didn't I? Okay, sorry about that. So our plan then, we need to go, they're both less than 30, so I ran a plot. Both looked fairly linear. Remember that you have to do sketches for both if it's less than 30. If one is less than 30 and the other is not, then you're good just to run a plot on one of them. Okay. There's my independence test, and it was randomly selected, was given. All right, here's my do. This, after I ran 1-var stats, I got this data on the 1-var stats. Okay. Plugged them into the formula and got this interval. Okay. The formula in the degree of freedom in the calculator was actually 13.1 whatever using the formula. So that gives me a little tighter, as you could see if you did it on your calculator. You got this interval here. This is by hand. This is with the calculator. They're both correct. Remember, the calculator is going to give you more accuracy, and so it can be tightened up. You can get a smaller interval and be confident that you're confident that it's in there. So you have more, less of an interval that you can use there. So then our conclusion is that we are 99% confident that the true mean difference, okay, in the number of chocolate chips between Chips Ahoy and Great Value is between, and then there's that number, -3. Okay, so remember that when you're doing the difference, notice I put up here, let's see. Well, I guess I didn't write it somewhere, did I? Okay, we should have we're doing x1 minus x2, so we're doing the Chips Ahoy minus Great Value. Okay, so you will get negative when Chips Ahoy has less than the Great Value. All right, so anyhow, here's your, if you ran the 2-samp t-test, I just put that down there. And remember, I just wanted to remind us how we're to cite all those pieces. I didn't put it on this paper, but it's in the notes. Remember, your sketch for confidence intervals is just your interval. Our hypothesized value in the middle, which is at the difference, is 0, and you have 99% around it. Okay, well, in this case, our 0 is in this 99% CI. 0 falls in here. So with that, we do have convincing evidence that there is a difference in the mean number of chocolate chips. Okay? So without running a significance test, we would have found that we were going to reject the HO and see, there is a difference between the generic brand and a name brand cookie there. All right? All right, those are good examples. Again, you have a couple of questions, I think 3 or something like that, 3 or 4, that you're going to work on and practice with this. Bring me all your questions to video conferencing time, and we start section 2 tomorrow.